Okay, so next we have Yong from Intel. He's based in Beijing, China, has been working on the Lustre project for over a decade through various companies, currently a senior Lustre engineer at Intel. Among his many contributions to the Lustre codebase is being the primary engineer on OpenSFS-funded Lustre file system consistency checker. Let's see, this is a topic near and dear to my heart. This is Lustre ZFS Snapshots. So, Yong, take it away.
Hello, everyone. Today, I will talk about ZFS solution on Lustre. Jinghai is my colleague, the co-author of this presentation. He helped on the snapshot test. Firstly, let's see how we can use the Lustre snapshot. Generally speaking, there are three scenarios for Lustre snapshot to be used. The first is to recover or undelete the specified files from the snapshot. Will be very difficult if without the snapshot. The second is that we can quickly back up the system before some big changes of the system. For Lustre users, it is quite normal that you need to upgrade your system, but upgrading is not zero risk. We will suggest the customer to back up their system before upgrading. But the traditional backup will be time-consuming work, especially consider very large system. The backup may take days. But now, with snapshot introduced, such work can be done within 1 minute. So snapshot quite simplified the upgrade process. The third is that the snapshot can clearly define the backup time point. Traditionally, the backup is async work. It may take hours or days to back up the whole system. So it is quite normal that during the backup, someone is using the system and modify some data. So when the backup is done, it is difficult to say what the data contained in the backup and at which time point the system is backed up. But with the snapshot, the things become clearly. After the snapshot created, even someone modified the system, the old data is still in the snapshot. The traditional async backup tools can work on the snapshot literally. Generally, there are several ways to implement the Lustre snapshot. The most ideas is to implement the integrated snapshot, but because it is more controllable and independent, but it's also more complex. Currently, consider the complexity and the functionality. At the first phases of snapshot 1, we choose a relatively simple and reliable solution. We will use the ZFS backend local snapshot mechanism to set up Lustre global snapshot. We plan to make such work to be released to community tree Lustre 2.10. Okay, this graph basically describes how Lustre snapshot works. As you can see, the Lustre snapshot user interface are implemented as part of the LCTL command set. The user will trigger the snapshot by LCTL command, and inside the LCTL API, the snapshot command are split into several sub-commands. These sub-commands either belong to Lustre control set or belong to ZFS control set. For the sub-commands in the Lustre control set, it will be handled by Lustre kernel and communicated among Lustre target via Lustre network. For the subcommands in the ZFS control set, they will be handled by Lustre LCTR API, LCTR logic directly, and dispatched to remote server via specified remote cell, and in further handled by the ZFS tools on the remote server. From next slide, I will introduce each commands one by one. Okay, let's see the global red barrier. This is the first subcommand. To guarantee the system namespace to be consistent during creating the snapshot, we will freeze the system during create snapshot pieces on every target. Please note that we only set the red barrier on the MDT set, not on the OST. Someone want to ask why. The reason is that setting red barrier on the OST will not bring more benefits to us, because from the logic view, flash the client-side kernel dirty date to OST is not complex. But as you know, the applications and the user space library may catch some user data in the user space. So even we can flash kernel space dirty data to OST from the application view, we still cannot guarantee the OST side data is complete. Since there is no benefit to do that, then we do not set red barrier on the OST side. For such purpose, we implement some new LCTR commands for the global red barriers, including barrier freeze for set up red barriers, and barrier throw to release the barriers, and barrier stat to query the barrier status on the OSTs. All these LCTR commands will be used by the snapshot, but they are not dependent on the snapshot and not inside the snapshot. This animation will show you how we set up global red barriers where two phases barriers configures. The first, the users trigger barrier freeze LCTR command. Then on the MTS, it will set the barrier status at freezing 1 and notify the MDTs by revoking the barrier logs. For the MDT, it will obtain the log from MTS. Then it knows someone wants to set the barrier. Then it will set its local barrier status at freezing 1 to block the subsequent client-sponsored modification. And then it will flash async RPC to remote servers. After that, it will notify the MTS, I have done the freezing 1. For the MTS, it will wait out the MDT to finish the freezing 1 phase. And then it will start the freezing 2 by revoking the barrier lock again. For the MDT, in the phase 2, it will get the barrier lock from MTS again, and then it will commit all the local transactions. After that, I will notify the MTS I have done the phase 2. On the MTS side, if all the MDT finishes the steps phase 2, it will set the barrier down and reply to users. That is the whole process. The next is about Lustre configuration logs. For Lustre, the file system name is the unique identifier of the system. Once the snapshot is created, we need to assign new FS name for the snapshot to guarantee it can be mounted together with the original file system. But the file system is not only a simple string in the file label, but also it exists in other places, such as is part of the config logs name, and it is also recorded in the config records. So because ZFS snapshot is strictly read-only, we cannot modify the data after the snapshot created. So we have to prepare the file system name and the related config logs before the snapshot to be created. And then, when created the snapshot, it can inherit such information from the original file system. For such purpose, we implement another new LCTR commands, including the focal LCFG for generate new config logs and FS name, and erase LCFG to remove specified config logs. Okay, we will talk about something for how to mount Lustre snapshot at read-only mode. It is not as simple as -OR mount option. It is more complex than that because ZFS backend, ZFS snapshot is strictly read-only. Any modification or attempt to modify the ZFS snapshot will trigger the backend failure or alert. So we have to be careful to filter out all the possible modification during the mount, including the following works. We will open the ZFS site at read-only mode, and not start a cross-server sync thread, neither pre-created thread, quota thread, and skip sequence file utilization, often clean up, recovery, and ignore last RCVD file modifications, deny to create transactions, and forbidden RCK, and so on. A lot of things. Okay, after introduce the Lustre control site, let's move to the ZFS control site. Currently, we support 6 LCTR snapshot commands, including create snapshot, delete snapshot, modify snapshot attributes, list the snapshots, mount and unmount the snapshot. Because time limit, I will not introduce them one by one, just some emphasize some of them. The first important command is create a snapshot. You need to specify the snapshot name when creating the snapshot. Please note, it is snapshot name, not a snapshot file system name. That is different. The snapshot file system name can be automatic generated. Generally, the snapshot name is just a short string, but sometimes it will be easy to be remembered, but sometimes some string is not enough to describe what the snapshot is for. So you can specify the comment. The comment can contain anything you want to say to describe what the snapshot is for. But anyway, if you can modify the comment and snapshot name after it is created by the command modify snapshot. Another useful command is list snapshot. Sometimes you may forget what snapshot you have ever created, and maybe you forgot when you created and when you modify it. For such purpose, you can use the snapshot list command. If you specified the -D options, it will give more detailed information for every pieces of the snapshot on every target.